On a quiet morning along the Florida coast, as the horizon glowed orange and the air trembled with anticipation, 4 astronauts sat atop a rocket so powerful it could shake the Earth itself, knowing that in just minutes, they would leave everything familiar behind and travel farther from home than any human had in over half a century. The mission was called Artemis II, and although it sounded like just another step in space exploration, it carried the weight of history, ambition, and risk in equal measure. For decades, the moon had been nothing more than a distant memory in human experience. The final footprints left during the Apollo era had long been untouched, slowly fading beneath lunar dust. Entire generations had grown up without witnessing humans venture beyond low Earth orbit. Space had become routine. Satellites, telescopes, robotic missions, but no longer deeply human. Artemis II was about to change that.
The idea behind the Artemis program had been building for years, shaped by shifting political priorities, technological breakthroughs, and a renewed sense of global competition in space. NASA's goal was not simply to revisit the moon, but to create a sustainable presence there, one that could support science, exploration, and eventually serve as a stepping stone for missions to Mars. But before any of that could happen, one crucial question had to be answered. Could humans still survive the journey into deep space? The answer would come from 4 individuals, each carrying not only their own experience, but also the hopes of millions. Reed Wiseman, the mission commander, had already spent months aboard the International Space Station. He understood the psychological and physical demands of space better than most. Victor Glover, the pilot, brought the discipline of a naval aviator and the historic significance of becoming the first black astronaut assigned to a lunar mission. Christina Koch, a mission specialist, had set records for the longest single spaceflight by a woman and would now become the first woman to travel to the moon. Jeremy Hansen, representing Canada, would be the first non-American to venture so far from Earth. Together, they formed a crew that reflected a new era, diverse, international, and forward-looking.
Their preparation was relentless. Training for Artemis II was not about learning something new. It was about eliminating the possibility of failure. They rehearsed every conceivable scenario: system failures, communication blackouts, medical emergencies, over and over again, until their responses became automatic. They spent long hours in simulators that recreated the Orion spacecraft down to the smallest detail. They trained underwater to simulate weightlessness, endured isolation exercises to prepare for the psychological strain, and practiced survival techniques in case of emergency landings in remote parts of Earth. Every moment of their training reinforced a simple truth. Once they left Earth, there would be no room for hesitation. At the center of the mission stood the Space Launch System, a rocket unlike anything NASA had built since the Saturn V. Towering over the launch pad, it represented both continuity and innovation, a bridge between the legacy of Apollo and the future of Artemis. Its engines, adapted from the Space Shuttle program, combined with powerful solid rocket boosters to generate immense thrust. Sitting atop it was the Orion spacecraft, designed specifically for deep space missions. Orion was more than just a capsule, it was a lifeline. Its systems had to sustain human life far beyond the protective magnetic field of Earth, shield the crew from radiation, and endure the intense heat of re-entry.
Launch day arrived with a sense of inevitability. At Kennedy Space Center, engineers monitored systems with quiet precision, while spectators gathered in anticipation. Around the world, millions tuned in to watch. Inside Orion, the astronauts were strapped into their seats, surrounded by screens and controls, their suits pressurized and ready. The countdown echoed through the control room and across broadcast feeds everywhere. When it reached 0, the engines ignited with a blinding burst of light and sound. The rocket did not leap into the sky immediately. For a brief moment, it seemed to resist gravity, as if gathering its strength.
Then it rose, slowly at first, then faster, carving a path through the sky on a pillar of fire. The ground shook, the air roared, and within minutes, Artemis II had left the atmosphere behind. The transition from Earth to space was sudden. The violent vibrations of launch gave way to silence. The force pressing the astronauts into their seats disappeared, replaced by the strange sensation of weightlessness.
As they unstrapped and began to move inside the cabin, objects floated freely around them. Every movement required adjustment. Even the simplest tasks became deliberate actions. Through the window, Earth appeared in full view, a vibrant sphere of blue and white suspended in darkness. It was both beautiful and fragile, a reminder of everything they had left behind. The journey to the moon was not immediate. It required precise maneuvers and careful monitoring of every system. Unlike missions to the International Space Station, Artemis II would travel far beyond low Earth orbit, entering a region where Earth's magnetic field could no longer provide protection from cosmic radiation. This was deep space, an environment that humans had not experienced firsthand in decades. Life aboard Orion settled into a rhythm. The crew followed a structured schedule that balanced work and rest. They conducted experiments, tested navigation systems, and evaluated how the spacecraft performed under real conditions. At the same time, they maintained their physical health through exercise, knowing that prolonged weightlessness could weaken muscles and bones. Despite the routine, there were moments of reflection. Floating near the window, an astronaut might watch as Earth gradually shrank in the distance, becoming smaller with each passing hour.
As they approached the moon, the reality of their mission became undeniable. The spacecraft entered a trajectory that would carry it around the far side of the moon, a region permanently hidden from Earth. When they crossed that threshold, communication was lost. For a period of time, the crew was completely alone. No voices from mission control, no signals, no connection to the planet they had left behind. It was a silence unlike any other, profound and absolute. Emerging from the far side, the view that greeted them was extraordinary. The moon dominated their field of vision, its surface revealing details impossible to see from Earth. Craters stretched across vast plains, mountains rose sharply from the landscape, and shadows marked regions that had not seen sunlight for billions of years. They passed over the lunar South Pole, an area of particular interest for future missions due to the presence of water ice. This was not just a flyby, it was reconnaissance for humanity's next steps. The mission was never intended to land, but its importance lay in validation. Every system, every maneuver, every response was a test. The success of Artemis II would determine whether future missions could proceed. After completing their journey around the moon, the crew prepared for the return trip. The burn that would send them back to Earth had to be executed with precision. Too little force, and they would remain trapped in lunar orbit. Too much, and they could veer off course. The engines fired, and the spacecraft adjusted its trajectory. Gradually, the moon receded behind them, and Earth began to grow larger once again. The journey home carried its own risks. Re-entry into Earth's atmosphere would be the most dangerous phase of the mission. Traveling at immense speed,
the spacecraft would encounter extreme heat and pressure. The heat shield, a critical component of Orion, would have to perform flawlessly. As they approached Earth, the crew secured themselves in their seats once more. The atmosphere began to thicken around the spacecraft, generating intense friction. Outside, plasma formed, glowing brightly and temporarily cutting off communication. Inside, the astronauts felt the increasing force pressing against them. It was a controlled descent, but one that left no margin for error. Then, at the precise moment, the parachutes deployed. The violent descent slowed and the spacecraft stabilized. Below them, the ocean stretched out, vast and calm. With a final impact, Orion splashed down, marking the end of the mission. Recovery teams moved quickly,
securing the capsule and assisting the crew. When the hatch opened and the astronauts emerged, they were greeted not just as individuals, but as pioneers. They had traveled farther than any humans in decades and returned safely. Their mission proved that deep space exploration was not just possible, it was happening. Artemis II was more than a technical achievement. It was a turning point. It demonstrated that humanity was ready to move beyond Earth once again, not just for exploration, but for expansion. The lessons learned from this mission would pave the way for Artemis III, which aimed to land astronauts on the moon, including the first woman and the next man. Beyond that lay even greater ambitions: lunar bases, long-term habitation, and eventually missions to Mars. For those who watched from Earth, the mission rekindled something that had been dormant for too long.
It reminded people that exploration is part of human nature, that the desire to go beyond the known is what drives progress. Artemis II was not the end of a journey. It was the beginning of a new era. And somewhere, far beyond the atmosphere, where the silence of space stretches endlessly, the path forward had already begun.